Okay, this is a word problem. There's a company selling hula hoops. This is their profit function right here, and this is, sorry, not profit. This is their revenue function. So that's the amount they'll sell, and the cost. This is their cost function. They want us to compare it. So we can graph the two, and we're going to quickly graph it by just using a graphing calculator, okay? Our blue is our cost function here, and our red was a revenue function. So we talked about this quickly. The points where these two quadratics intersect each other are the break-even points of the company. That's where the revenue is equal to the cost. In other words, profit is 0. Now here, this is where R is greater than. So revenue is greater than cost, and this is where we're profiting, right? And our profit would be greatest where the distance is the most. And then eventually, once our cost function, where C is greater than revenue, so C is greater than R, then we're losing money. So we lose money if we don't sell anything, right? It costs us money to start up and we make no revenue, and anything beyond this 7.81, which is I think in the thousands they said in the question, that's where we would lose money in our question. So one way we can figure that out is to figure out where the 2 points of them are, is we can set the two equal to each other to find break-even points. So say I was having trouble graphing it and I just want to know my break-even points. Well, one of those things would be where I would set R equal to C. Okay, so let's set these two equal to C and find our break-even points and see if we get what they had. So negative 0.2n squared plus 3n is equal to 0.1n squared plus 0.4n plus 2. Great. Let's move on everything to one side of the equation, so I can move everything to the right, okay? 0 is equal to 0.1n squared. This will become plus 0.2n squared plus 0.4n. This will become minus 3n plus 2. So we'll collect our two like terms, 0.3n squared. This will become negative 2.6n and then plus 2. Okay? So we have this. This is our new quadratic. So this gives us a new function. And instead of going through the whole process of finding x-intercepts and stuff, we're going to graph this. We'll quickly go over. So 0.3, negative 2.6, and 2. So 0.3, negative 2.6 and 2. Is that right? That's right. So if you notice, one of our break-even points is 0.85 when those two cross. By graphing the new equation we built by setting them equal to each other, 0.85. So the x-intercept is actually representing our break-even point, which is the exact same over here. Our x-intercept, again, represents that break-even point and how many we need to sell. If we go back to the equation, we can find out where it's greater and less than, okay? So now that we know, so we could have gone through the process. We could have gone through the process of finding those x-intercepts ourselves. Oops. And when we would have done that, we would have found our two x-intercepts, and we're going to write them in. One of them was where x-intercept was equal to 0.85, right? And the other one was equal to 7.81, okay? What we want to find for the company is when R is greater than C and when C is greater than R. Okay, we know at those points that's when R is equal to C, so revenue is equal to. Here's where we're going to make money. Okay, when R is greater than C. So essentially, we take a value in between those. I'm going to take something less than, so 0 will be one of the values I'm going to test out in my equation. And because we know it's quadratic, from literally figuring that out, we know the pattern of a quadratic, right? In fact, we don't even have to test those because this is quadratic. We know that our x-intercepts are at 0.85 and 7.81, right? And because the a value is positive, we know it must go down and up like this. This is our new profit function, okay? So I'm going to say, technically, they put 0 is equal to, but this is our new p at n. This is our new profit function, okay? P at n is equal to this. So with our profit function, what that means is, what we have here is our C is greater at any point here. This is when we've lost money. This is where we've gained the most money. Okay, we gain the most money here. This is where our profit is. And if we go back and look at the function, it's the exact same thing. This is where we'll generate the most profit. So from our profit function, we would have just found the vertex of it. We would have gone through that process of finding the vertex. And it turns out our biggest difference is when we sell 4,000 or 4.33 because it was in thousands. At this specific point, it's about somewhere in there, right? That's where the biggest distance is. And we can look at that. That's where the most profit is in this question here. Sorry, I completely lied. This isn't the profit function. Why did I say that? That is where we make the most profit. But our profit function, I'm not sure why I wrote it that way. Our profit function is when R minus C, revenue minus cost. So we're going to take those two functions and solve from there. That'll give us our new profit function. The other one just gave us our functions when we set them equal to each other to find our x-intercepts. They still tactically represented where our profit would be. Our profit function, so we'll take these two. Oh, that's actually what I ended up doing. So it is our profit function. Sorry, I got confused myself. Because I took R and moved it over, right? I took this entire side and moved it over here and subtracted. That's what this, sorry, not that one. That and, what's going on here? Oh, there you go. Not sure why it's doing that. This and this occur, right? So those two things coming over, that's where I move my revenue over here. So although I set it equal to 0, oh, I'm in this version, that's why it's doing this. So I set it equal to 0. When we move our revenue over, we set it equal to find out those exact intercepts where the break-evens were. But when we move it over, we essentially ended up with revenue. Actually, we did cost minus revenue. Okay, so it isn't technically a profit function because we have it upside down. This would be considered like a loss function. So if we did it the other way around and I moved the C over this way, I would have ended with my profit function in that case. And our profit function, which makes sense, because when we do that, we're going to actually get a downwards facing parabola when we do that. So let's do it the opposite way. We did kind of a loss function. I guess I should have set it up a little nicer. So let's do it the other way. Our profit function, so P at X, is equal to the revenue function, which was here, negative 0.2 n squared plus 3. Is it? Plus 3n. Okay. Subtract our other function, which was our cost, 0.1 n squared plus 0.4 n plus 2. Okay. This is essentially what we did over here when we set it equal to 0. I'm just doing it in the opposite way, and that's, you'll see we'll end up getting an inverted one. So when we do it this way, okay, because it's a negative, we bring that negative out. 2 n squared minus 3 n minus 0. No, sorry, that's a plus. This becomes minus 0.1 n squared minus 0.4 n minus 2. Just make sure I wrote those right. Yeah, I did. Okay. When we collect our like terms, this becomes negative 0.3 n squared. This here becomes positive 2.6 n, and that becomes negative 2. So if we take a look at, let's see if I can get them both on the same screen. If we take a look at this, this function here is very similar to the other one we built up. This one here. I'll zoom out just a little so we can see them. Sure, that's good. Perfect. If you notice, it's the inverse of this function. Okay? We've essentially inverted the entire function. And when we go to graph this, because this was a lost one, our profit one will make a lot more sense. So I'll draw the inverse of what we had here. Negative 0.3 x to the power of 2 plus 2.6 x and plus 2. We get the inverted function. Okay? And there's a lot of graphs going on right now, so let's just move those two away. We got the inverse of what we had before when we were doing this. Okay? Our x-intercepts, did I write that right? Oh, no, that's negative 2. There we go. I was like, that's not technically right. There we go. Our x-intercepts still cross at the same point, and this is telling us our profit. And this makes more sense for profit because without the green one. When we come above, so when y is positive, that's when we're making money. This is when we make the most money. And this is where we go back to breaking even again. Okay, so I use a graphing calculator to skip a lot of the not tedious, but the harder parts of setting this up, because to set this up, we would have had to do a lot of graphing, and we would have had to find a lot of x-intercepts, completing the square. We'd have done it like 4 or 5 times. But that's the general idea of that inequality. Okay.